So I'm going to introduce our next speaker, Maxim, who's been waiting patiently here, as you can imagine. And he's going to be talking about easy scaling of Ignite applications in a dynamic Kubernetes environment. So without further ado, I will hand over to you.
Okay, hello everyone. Hope you're going well. So my name is Maxim and I'm going to tell today about our experience of scaling Ignite applications in Kubernetes. We will touch such topics like data partitioning, different types of Ignite clients, and I will talk about a new feature we add to Apache Ignite that solves our problem with sharing, with scaling of applications. So a few words about me. I'm a software developer in SberTech. It is one of the biggest IT companies in Russia. Also, I'm a contributor to Apache Ignite, and I'm the author of the feature I'm going to tell today. So if somebody wants to be in contact, there are some my links to my GitHub or LinkedIn. You're welcome. If you have any questions, you can ask them in the chat and I will answer on them in the end of this session. And so let's get started. So this is a very simplified picture of our system. We have a lot of data from different sources. There are a lot of mobile data, web applications data, geo data, financial transactions, buyers, sales, and etc. And all this data is input for our system that can be in simple form represented with a set of services that run around Ignite cluster within a Kubernetes, and output of our system is some data that used for analytical purposes, storing in external data storages, or returns to users through the web pages. So let's look closer to our system, and it looks like that. There are a set of stateless services, and there is a separated layer where Ignite cluster running and stores the state. So in very simplified form, they use a cacheware for inter-service communication. For example, we have some data that our service has, and it wants to put this data to the cluster, and some other services wants to put the data, fetch the data, and use it for some ways. Or, for example, the same service that put this data to the Ignite cluster can store with it some state that it will fetch it again to restore the state for some other operations. So it's pretty simple. So we split our system on two layers, services layer and cacheware, and we do it by the reason that there are different patterns for scaling applications and the cluster. The main requirements for our system is latency, and it means when we see the growing queue of the data on the input for some service, we can decide to scale it up to increase the throughput, and from other side, we can decide to downscale some our service if we want to save some resources. And Kubernetes makes it very easy, and this is the reason why everybody in world love Kubernetes, because it provides a very easy way to scale your applications. But when you're working in the distributed system, we should be aware of some problems that you may have when you are scaling your application. And actually, it's not very simple to make this works for distributed database. So to describe which problems we had, we need to more some details. And first thing, we should understand how exactly services put their data to the cluster. And first thing, we should to know that actually all data in Apache Ignite stores in partitions. It means that it used for optimized processes of data persisting or data transferring, and it means that we need some function that that maps our data to some of partition. So there is a function, let's name this partition function, that applies on a cache key, and it returns the partition number. So the second thing we should know that a partition is a unit of data distribution. When you run your Ignite cluster, it runs some copies of your data. So when you accidentally lost your node, it doesn't mean that you lose your data. Actually, there are some copies and you don't lose any data. So as we have some copies of our data, it means that there is a one primary partition that means that when there are some operations in the cluster that are related to the partition, then these operations should be applied first to the primary partition. And then Ignite cluster automatically propagates these changes to other copies. So for our applications, it required to be aware of where the primary partition is located. So there is another function, let's name it not function, that applies on two arguments. The first one is the partition number, and the second one is the current state of the cluster. Actually, it is a list of alive nodes in the cluster, and it returns the returns the node where the primary partition will live. So we should know that these functions are stateless, and it means that from any side, from client side and from the server side, you can invoke them with the same input. They will return the same result. So it is very simple from cluster side. So let's discuss what is going on if you decide to scale our cluster. As already said, there are different patterns for scaling your applications and your cluster. As the main requirements for application is the latency or resources usages, there are different requirements for scaling your cluster. It may depend on the amount of data that stores in your cluster. It depends on some configurations like whether the persistence is enabled or not, and some etc. So when you decide to scale your cluster and add new node, it triggers the process of moving partitions between nodes. It means that some of partitions changed their locations and started to fulfill the new node. And this process is optimized for Apache Ignite, and it means that there are only few partitions started to change their locations, but this process is still costly. And this is the reason why you should not to scale your cluster frequently. And this is the reason why we use Ignite cluster as a caching server and don't use other patterns like embedded caching or sidecar container, because we need to scale our applications frequently. So from cluster side is pretty simple. So now we need to understand what exactly is going on the client side. So when Ignite supports some types of client applications, and the first choice you have is running a client node. The client node means, and you can think about client node as about server node, but it does not store any data. So no partitions are stored locally for client node, and it relieves the memory pressure on your application. But the client nodes share the same code as server node does, and there are a lot of common processes. And it helps us when we're configuring our applications. When you configure your Ignite cluster, you start your server node with Kubernetes IP Finder, and it helps cluster to find nodes that lives in the cluster and build a topology. And you can configure your client node with the same Kubernetes IP Finder, and it will work out of the box. So this is a very good advantage of using client node. So when you configure your client, then it tries to connect to the cluster to one of the server node, and this process triggers some process that goes around the whole cluster. So every server node in the cluster should be notified about that client is connected and change topology. because client nodes are connected to the cluster and change their topology. Also, it means that every client applications you have in the cluster will also be notified about change topology. And it does not trigger any partition moving in your cluster, but still consumes some time and resources. So after that, our client is connected to, and now it is available for sending requests to the cluster. So let's check what is going on when we decide to downscale our cluster. As we already talked, it started the process of moving partition started, and our client nodes automatically notified about it and get information about actual not about actual state of the cluster automatically. And it means that every time you change your cluster topology, your client nodes automatically knows where the primary partition live and can access directly to the required node to put operation, for put or get operations. So from this point of view, it looks like the client node is a very good choice because it supports after discovery of Ignite cluster. It always aware of partition locations. It supports all new features out of the box. As already said, a client node shares the same code as server node does, and it means when a new feature appeared in Ignite, then client node will automatically support it, and it decreases time to market for some new features and is pretty well. Also, client nodes can coordinate transactions, and the last thing I want to say is that client nodes support such features as near cache. As already said, client nodes does not store any partitions data locally, but if you have some cache that changes rarely, for example, once a month, it's like can be some dictionary, city dictionary, or something like that. Then you can configure your connection to this cache with near cache, and it will store locally some frequently asked case from this cache, and it can speed up some operations and relieve the network stress for your cluster. But when we're talking about cloud or Kubernetes, we should be aware of some moments in the client node. The first one that is not tiny enough. The last week I tried to start it on my laptop, and it requires about 60 megabytes just to start. There wasn't any useful operations, just start and get 60 megabytes. And when you have a lot of clients, it can make a big pressure for your system. The same thing you should to have in mind that client nodes consumes resources of the cluster and your applications because they are automatically notified about changing of partition. It means that there are some additional data structures, additional threads that are running in the background and consumes your CPU and memory. And if you have, the more clients you have, the more resources your cluster will spend for these actions. The another things we should have in mind that compatibility, that client node are compatible only with the cluster with the same versions. It means that when you want to upgrade your cluster and switch to another version, you have to upgrade every application in your system because they must be the same version. And because we have a lot of team with different processes, it's very painful to synchronize them in one point of the time and try to upgrade simultaneously. Another thing that we had that as your client connects to the cluster and it triggers the process of notification every node in the cluster, it requires a time. It means the more clients you have, the more cluster you have, the more delay between your application actually starts and your application is ready to run some useful operations. And it can take some seconds to be available. And for some cases, when we had a very big cluster, it took about some clients are time-mounted, so they waited too long to be notified from the cluster, and they're disconnected. And it means that every application in your system should be notified, should be aware of this situation, and should correctly write a code of handling those situations. It's not very convenient, I think. And the last thing that not clients are Java stack only. They're written in Java because the server are written on Java, and there are no any chances to switch into another stack. And it's not very good for us because we have some teams that uses different languages like .NET or Python. So to eliminate those problems, the thin client was designed. It written separately from server node. It almost not shares the same code, and it means we can configure our client application the same way we can do it for client node. As we can see, we configure our cluster with Kubernetes IP Finder, but from other side, we should configure our application with addresses of the Ignite nodes to have a communication. And the simplest way to do it in the Kubernetes is to configure your client with the address of the service, and then Kubernetes automatically connects your client with a random node from the cluster. Actually, it runs an ordinary TCP connection by simple binary protocol, and after establishing TCP connection, everything works. There is no any resources consumption, there is no any delays, it just works, and this pretty perfect. So now let's try to understand what is going on when wants to put some data to our cluster. So we connected to one node, and primary partition is located to another node. So in this situation, Ignite proxies our request to the required node, wait for responses, and then proxies it to the client node. And as you can see, there are two additional network hosts, and it's not very good when we have a lot of clients and a lot of requests, and it creates pressure on your network system and affects your latency. So to eliminate this, there is a feature, partition awareness, in clients, and actually it is enabled by default. And this feature helps your clients to be aware of partition mapping, current partition mapping in the cluster. For example, to run it in Kubernetes, you can configure your cluster with stateful set, and it provide the predictable naming for Ignite pods. You can create a prefix like IGN, and then every pod in the cluster will be automatically naming with prefix and counter. So we can, in this case, configure our client with two nodes, IGN1 and IGN2, and let's see how it's working. So at first, our client connects to every configured node and then asks a random node for actual partition mapping. And after one node responds with that, the local map of partitions is updated on thin client. And now we understand that we have a partition, we have an address of node that we can address our request. Then for our data, we just go into the required node, and it works perfectly. So it means that we can configure our client with a list of all nodes in the cluster, and everything will work as expected. But what is going on when we want to scale our cluster again? So we add a new node, and we are not lucky enough, and our primary partition was moved from IGN1 to a new node. So in such situation, our client still has information about location of partition 2 on the node number 1. So it tries to request it. The request is proxied, but also client in this moment is notified that partition map is changed. And after client tries to refresh the information, it found that there is no information about partition number 2. we don't have it because we don't configure the connection to the new node. And this is a limitation of Ignite, that a limitation of clients, that they know only about configured nodes. And it means that every time you want to scale your cluster, you should to reconfigure all your clients again. And as already said, it is painful. So, and we decide to solve this problem, and we teach our clients to work with dynamic list of addresses. We extend configurations of extend the client configuration and add a new setting, client address finder, that accepts a simple function that should return the actual list of alive nodes every time it asks for. So, for example, you can have some external storage. It can be console, can be Git, or can be some file in distributed file system. The only goal of this file of this storage is track the actual state of your cluster. And when client notified about that cluster topology changed, it goes to this address storage and fetching the actual state of the cluster, and then decides what to do with new connections and establishing new connection or removing obsolete connections. So this using of external storage can help us in some situations. The first one, if you have, for example, you have some different clusters in your system, for example, it's staging or maybe A/B test, and you want to switch in your clients from one cluster to another cluster, and from one cache to another cache, and you can do it simply using this external storage. There's another situation that can help you is a fast restoring connection after downscale. What I mean, when you have a cluster and a client connects to every node in your cluster and you want to downscale, it means that your client still has connection to the obsolete node. And it may situation when your client will try to connect to this node. And there will be times that that client will understand that this node is actually down and it should try to another node. But you can replace this, avoid this situation by configuring the external storage. And every time topology changed, it just checks address storage and nothing delays. It will work very fast. Another feature that can be used here is attribute node filter feature. This feature helps you to run cache on some specific nodes. So by default, when you run your cache, it automatically distributed over all nodes in the cluster, but you can configure some of your nodes to hold specific cache. And then you can configure your clients to connect to a specific node that stores required cache and does not establish connection to other nodes. So I see such cases that can help us. If you see some others, you can chat me and we can discuss them later. But if you don't have such complex networking, for example, you don't have staging or you don't use node filter and just want to client to work automatically, you can just replace address storage with the Kubernetes. So how it's working? When you configure your Kubernetes with IP Finder, it's actually on start just goes to Kubernetes master node and ask which IPs are registered for Ignite service name. And Kubernetes just responds on with the ordinary HTTP response that there are available pods running within the service. And cluster then find IPs of every node in the cluster, and it helps him to establish connection and build topology. So using client address finder, it's very simple to do the same for your client node. We create a simple implementation of address finder and client Kubernetes address finder. They are available in open source that help you to configure your client's node automatically. On the start, on every time topology change, it just asks a Kubernetes master node about available IPs by ordinary HTTP request, and then after that it will respond, and client can handle changes in the topology. So in this situation, we can see that thin client now have, after discovery of Ignite cluster out of the box, it is aware of partitioned locations thanks for partition awareness feature. It is very lightweight. It takes only few megabytes on start. It doesn't consume any resources, not resources of your application, nor resources of servers, not resources of other clients. And it's a great feature that is compatible in both directions. It means that you can run your Ignite cluster with version 2.11 and your client can be 2.10 or 2.12 and it will work out of the box. So there is no need to synchronize different teams to upgrade your cluster. But there is something you should have in mind. It doesn't affect us because we have a pretty simple operations, but actually clients have some lack of feature. So, for example, it doesn't support peer class loading or have limited implementation for data streaming. But we have an active community, Java, .NET, Python, and C++ clients. And if you have some feature request, you can create a ticket in the Jira, and one day it will be implemented. Or you can implement it by self, and our community is very friendly, and you are welcome for new contributions. So if you have any questions, I'm ready to answer on them now. If you will have any questions later, you can address them to the user list. If you want to contribute or have some requests for some features, you can write to the dev list. You can check examples of client address finder on our GitHub and in our docs. So thanks a lot for listening. If you have any questions, I will answer on them.
Thanks, Maxim. First question, does the cluster stop responding to client queries when PME is in progress? If not, does it guarantee complete/certain results?
Oh, okay, it's a great question. Actually, Premiere is it is very optimized process, but it still has a moment that is like stopping the world. So in very short time, yes, it's doesn't send responses, but it depends. Yes, so you need to test here because it depends on amount of data, because amount of partitions that are moving between your nodes. But yes, we have some timeout in this thing, but it's guarantee complete results. So this it's a tested process. So if you have request some partitions that change their locations, it still will respond with correct result. And as far as I know, there may be some issues, but actually I'm not aware of them.
Cool. So there's a follow-up question on that. If there's a very actively updated read-write data cache, do you suggest thick clients with near caches or thin clients?
So as already said, the near cache is aimed to be for situations when you have a lot of reads and very low writes. So it means that you have some dictionary that updated once a month. It means that you can use near caches. This near cache has a very high cost for write operations. And if you want to write, pretty frequently, it's not very good idea to use a near cache. So use thin clients, I think. But also you should understand it depends on some of your cases and some of data and how you want to put data.
Okay, great. Next question. Is there some documentation about best practices on handling really big clusters, 50 plus nodes or so?
You can ask them on user list. I'm sure that there are some topics on YouTube, or maybe some topics are written somewhere on Gridgain site, or somewhere we can try to find in the Google, but actually I'm not aware of them. We have our internal, in our company, we have some Confluence that is hidden from the public internet, and we have some information here, but you can ask in the user list, and you will get a link if there are any.
Okay. The next one is it recommended to have multiple thin clients?
Why not? Yep.
Yeah.
You just use it.
Yeah.
I think it was last week, my colleague tested about 1,000 clients connected to a cluster with 4 nodes, and there no any problem.
Okay. I think that's it for the public questions, but I have one before I introduce our next speaker, just quickly, because we have a few minutes left. So as far as I understand, this feature, the client address finder, was developed for the Java client only. Is there some alternative for other languages, Python, .NET, etc.? And which version of Ignite was this done with?
Yes, it's implemented in version 2.10, and it's implemented in Java, yes, but there are some other alternatives in different languages. For example, in Python, by dynamic structure of this language, there's another way to configure and connecting the clients to the cluster, and you can implement this by just using your language easily. For .NET language, as I know, it supports service discovery out of the box. I'm not sure that it works okay for Kubernetes. It will be tested, but it works in some different way. It just asking a list of IPs, not from the external storage, but from the this cluster. And there may be some issues because you can have some multiple IPs addresses for a host machine, and there can be some things to test before using it.
Okay, and the last 30 seconds, what about AWS and GCE? Are there IP finders for those, and the client address finder for thin client?
Okay, as already said, the main thing we do is implementing the ability to run with a client with a dynamic list of addresses, and then we implement this interface, client address finder, with Kubernetes, and it's pretty easy to do. You can check our code, and actually it just shares the same code as server node does. And you can check our Ignite extensions repository, and it already has IP finders for AWS, for Google Cloud, and you can just share the same, get this code and use it in your client address finder. It's pretty simple, and you can do it by yourself. Or you can contribute and provide the default implementation for address finder to your work.
Okay, a last question, and then we'll go to the next speaker. What is the largest Ignite cluster you've worked with?
Actually, I'm not work with Ignite clusters. I'm developing them. Our clients running the cluster about 150 nodes, about that.
Okay, great. Thank you for your talk. We are out of time. I'm going to move on to the next speaker, but again, thank you for your talk, and
Thank you. Bye-bye.